When light passes through a transparent or translucent medium, it changes its direction inside that medium. If it enters a rarer medium from a denser medium, such as from water to air, it bends away from normal, and when it enters from rarer to denser medium, it bends towards the normal. We have also studied that magnitude of bending of light ray depends on refractive index of the medium. For example, if refractive index is more, light ray will bend more, and if it is less, light ray will bend less. This refractive index acts differently for different colors as it depends on wavelength of the light rays. If we compare the wavelength of visible light, violet color has least wavelength and red color has maximum wavelength. Velocity of a wave depends on frequency and wavelength. When wavelength is higher, velocity is higher, and when wavelength is small, velocity of that wave is low. For a medium, refractive index depends on wavelength, or speed of light in that medium. If speed of light or wavelength is more, refractive index will be less. The white light that we see, coming from sun, is actually not white, but a mixture of 7 colors: violet, indigo, blue, green, yellow, orange and red. When the white light passes through glass slab, due to different refractive index for different wavelength, different color bend at different angles. Violet color has least wavelength, so it bends more, and red has maximum wavelength, so it bends less. All other color bend in between these two colors. You can see that after refraction, white light divides into different colors. This phenomenon is called dispersion of light. For a medium, where both the surfaces from which light enters, and from which light leaves, are parallel, dispersion is not observed outside of it. This happens because light rays again combine at the time of leaving the medium. But when we use prism where surface of incidence and surface from which light leaves are not parallel, we observe the dispersion outside the medium too. This happens because angle of incident changes while entering and leaving the prism. This results in different color rays leaving the prism from different locations. If we again let these dispersed rays pass through similar but inverted prism, these rays will emerge from it as combined form. You must have seen rainbow just after some rain. This happens because water droplets act as prism and disperse light in sky.